here we're going to look at topic 72, example 4, find the zeros of a quadratic function. So this is what we did in the last example. We had an equation that we solved, we found the zeros. We're going to do the same thing. They've just put it in the context of a real world scenario. So a multi-level driving range has 3 levels, and Marco hits golf balls from the second level, which is 32 feet high. The height of a ball x seconds after Marco hits it is modeled by the function h of x is equal to negative 16x squared plus 16x plus 32. When does the ball hit the ground? All right, so what we're going to do is we're going to look for the zeros here, and we're going to look to solve this equation. So we have h of x is equal to this. We're going to take h of x and change that to a 0. So we're going to say 0 is equal to negative 16x squared plus 16x plus 32. The reason that we're making this 0 is because this function is measuring the height of the ball. When the ball hits the ground, the height is 0. So we want this height here to be 0. So we set it equal to 0. Now, in this problem, it looks like I'm going to need to use the AC method. However, I really do not want to have to do negative 16 times 32, which is negative 512. And I don't want to find factors of negative 512 that add up to 16. So fortunately for us, these 3 terms actually have a greatest common factor. I can factor out a negative 16, and I'm left with x squared minus 1x minus 2. And that becomes a significantly easier problem to solve. Okay, so anytime you have numbers like this, you always want to look for a greatest common factor. And it's important to note that negative 16 goes into all 3 of these terms. So since it does, I'm going to factor that out. All right, now from here, I can look at this piece here, and I can factor that. So I want to look for factors of negative 2 that have a sum of negative 1. So factors of negative 2 that have a sum of negative 1. All right, this one's pretty easy. Factors of negative 2 are 1 and negative 2, negative 1 and positive 2. That's it. Those are my only options. When I add them up, negative 1, this one works. This one's a positive 1, this one doesn't. So my factors are 1, negative 2. So what originally looked like a pretty difficult problem was cleaned up pretty quickly. So negative 16, right, this would factor, or the factors would be x plus 1, x minus 2. Oh, that's not what I meant to do. I want to highlight that. There we go. All right, so I've now factored this problem, and I can use the zero product property. The negative 16 doesn't factor into my zero product property. I don't really care about that part. So what I'm going to do is say x plus 1 is equal to 0, x minus 2 is equal to 0. So subtract 1, x is equal to negative 1, and add 2, x is equal to 2. Now, if this was not a real world type problem, we would just say that those are my solutions. X is negative 1 and x is 2. However, we need to be careful because the value of x represents seconds, and we can't have negative seconds, right? We're looking for when the ball hits the ground. X being equal to negative 1, this makes no sense, right? The ball can't hit the ground after negative 1 seconds. So this is what would be called an extraneous solution, or maybe not so much an extraneous solution. Sorry about that. I take that back. This is a solution that just doesn't fit our problem. It does work for the equation. If you plug it back in, it will work. However, in the scenario, it doesn't make any sense. So we are not going to use that as a solution, although mathematically it does work. So ignore my statement about extraneous solutions. X equals negative 1 is not a possibility for this specific problem. However, x equals 2 is a solution. So when does the ball hit the ground? the ball hits the ground after 2 seconds. And then that would be our answer. That's it. So solving that using the factor sum method and then using the zero product property will get us the solution that we are looking for.